The dream of 500km/h super high-speed rail travel has become a reality. In 2027, the superconducting maglev will operate on the new Chuo Shinkansen line. On today's program, we experience a ride on the maglev test line and look at the big picture of Japan's next-generation high-speed rail service. Welcome to Japan Railway Journal. Today's program is all about the superconducting maglev, which will operate on the new Chuo Shinkansen line due to open in 2027. So today, we're here at the Yamanashi Prefectural Maglev Exhibition Center. Here at the center, visitors can get up close to the superconducting maglev. As well as stepping inside a vehicle that was used on earlier test runs, guests can learn about superconductivity through interactive devices and experience a floating ride for themselves. The lobby is also extremely popular because here, visitors can see the superconducting maglev flash by their very eyes. So very soon, the superconducting maglev will be passing by us at 500 kilometers per hour. Wow!
Oh, 来た。
Wow!
早い。
Wow!
So fast.
So fast!
More.
We went in a fraction of seconds.
Gone!
息つく暇もなかったですね。いやー、あれだけ速い乗り物を作り出すまでには、もう技術者の方々のさまざまな努力が加わったんでしょうね。
Yes, since 1962, the engineers knew that it was the superconducting magnets that would make this system possible.
So let's find out a little more about it. The Railway Technical Research Institute began working on a linear propulsion system in 1962. With the aim of connecting Tokyo and Osaka in just 1 hour, development of the successor to Japan's famous bullet train had begun. 10 years later, in 1972, they successfully built the world's first superconducting maglev vehicle. With the test line being only 480 meters long and factoring in the stopping distances required, the vehicle wasn't able to run at more than 60 kilometers per hour. For that reason, in 1977, the Japanese National Railway constructed a 7-kilometer-long test line in Hyuga City, Miyazaki Prefecture. The first test vehicle was the ML500. The 500 in the name was an indication of the developer's intention to reach the 500 km/h mark. The ML500 did just that in 1979, when it set a new world record for an unmanned run with a speed of 517 km/h. In 1980, the inverted T-shaped guideway was changed to a U-shaped guideway, and the vehicle was made more box-like with space for passengers. The new vehicle was named MLU-001, the added U standing for the new U-shaped guideway. Numerous test runs were conducted with the MLU-001, and when safety had been checked and rechecked, the first manned run was made in 1982. Then, in 1987, the MLU-001 set a new world record for a manned run after achieving a speed of 400.8 kilometers per hour. In 1995, the MLU-002N set a world record speed of 411 kilometers per hour for a manned run. However, because the Miyazaki test line was only 7 kilometers long, vehicles could only run at high speeds for around 1 minute. For practical testing, a longer test line was needed, and so construction began on the 43-kilometer-long line in Yamanashi. Test runs on the new Yamanashi maglev test line began in 1997, and in 1999, a speed of 552 kilometers per hour was achieved, breaking the previous world record for a manned run. Then in 2013, the new L0 series, the model that will actually be put into operation on the line, debuted. And 2 years later, in 2015, it set a new world record of 603 kilometers per hour.
are big over there, isn't it?
That's right, and today we actually get to ride it too.
I'm so excited.
Me too. And this superconducting maglev technology is something that Japan can be proud of, a very advanced one. The engineers have had a very great effort to actually realize it, and we're seeing the fruits today.
I can't wait. Let's get an overview of the new Chuo Shinkansen line. The Chuo Shinkansen line will initially run from Shinagawa, Tokyo to Nagoya, passing through 5 prefectures between the two cities and the Japanese Alps. Most of the 286-kilometer line will run through a tunnel. There are plans to then extend the line to Osaka by 2045, although the route is yet to be finalized. This means there will be 2 high-speed lines connecting Tokyo to Osaka, but because the Tokaido Shinkansen is a major transport artery, the new maglev line will provide a welcome alternative route, especially in the aftermath of a major disaster. On December 18, 2015, construction began on the most difficult section of the line, the section passing through the Japanese Alps. In January 2016, construction began on the terminal at Shinagawa Station in Tokyo. Construction will cost an estimated $45 billion, all of which will be covered by the Central Japan Railway Company themselves. The fastest service between Tokyo and Nagoya will take just 40 minutes. That's 50 minutes faster than the Tokaido Shinkansen. It will take an estimated 1 hour 7 minutes to make the journey from Tokyo to Osaka. The train's top operating speed will be 500 kilometers per hour. Each train is estimated to carry around 1,000 passengers. In order to reduce air resistance, the ceiling has been lowered and the car's cross-sectional area has been reduced to less than that of the Tokaido Shinkansen. Because 86% of the line is in a tunnel, the focus is clearly on speed rather than a view for the passengers. There are also efforts to export the technology to the US.
We released $27.8 million in the US to complete a study of the connection between Washington, D.C. and Baltimore using this technology, and so that study will go forward.
The Japanese government is contributing around $7 million for developing possibilities for the technology in the US. The first line will initially run for 60 kilometers connecting Washington, D.C. to Baltimore, which will take just 15 minutes. The line will then be extended 360 kilometers to New York, connecting the two cities in just 1 hour.
Tokyo 東京から名古屋まで40分なんてもう飛行機みたいですよね。
Yes. Once the Chuo Shinkansen opens, that will make Nagoya and Tokyo belonging to the same metropolitan area, and that will, spark various innovations like the economic innovation or industrial innovation or even cultural innovation. So impact should be very huge.
もう名古屋から東京まで通勤できちゃいますね。
And I've heard that, compared to the Tokaido Shinkansen now between Shinagawa and Nagoya, the price increase is only going to be around $6, so it will cost around $100. That's it. So cheap.
Yes. So once the line extends to Osaka, the airline industry would have probably no chance of actually continuing their service from Tokyo to Osaka.
小さい時からリニアの話はずっと聞いてたんですけど、いよいよそれが実現するんですね。
So using these superconducting magnets to literally lift the train off the guideway is truly amazing technology. So let's find out a little more about it.
The system works by using these superconducting magnets installed on the vehicle and metal coils installed along the guideway. Together, they generate a magnetic force that lifts the train about 10 centimeters above the guideway, and it runs at super fast speeds. When metal is supercooled, its resistance to electricity becomes zero, a phenomenon we call superconductivity. The coils are closed and in a superconductive state, so when a permanent electric current is passing through them, a stable magnetic field is generated. A linear motor is a conventional electric motor that you find on trains that has been unrolled into a straight line. The superconducting magnet mounted onto the vehicle itself is the same as the moving rotor part of the motor, while the coils installed along the guideway are equivalent to the static stator part. A superconductive state is produced by using liquid helium to cool a niobium titanium alloy to near absolute zero, that's minus 269 degrees Celsius. To make the superconducting maglev vehicle levitate and move requires a really strong magnet.